So here we are on the second last part of our journey. The previous one was quite easy, as you have figured out. After doing differentiation, integration was just a cup of your tea. And again the binomial theorem, the playing with index, it was again a bit easy, okay? But in this part we are going to play with the number of terms. And mind it, it's not that easy. While playing with the index, it was just a single formula. But here I have kept it specially for the end, although most of the students are having problem in this part. And as they say, that was just a trailer, picture abhi baki hai. So you will gonna watch the remaining movie in this part. Let's begin with the part and enjoy the show. Starting with the multinomial theorem here, we are going to look first that until now we have just discussed the two term expansion. Now multinomial will be referring to more than two terms at a time. As here you can see, the theorem says that the expansion of this kind, okay. Now the limiting case of this was the binomial, in which we were saying x1 plus x2 raised to power m, okay. That was the limiting case. Now here, if I have an expansion of this kind, how will I solve, okay? So here it will be saying that the total number of terms in the expansion is, now for this a prerequisite will be the knowledge of combination, and in specific if I talk, it will be about distribution. So here basically what we are doing, even in the binomial, now going to that thing which I promised you in the beginning, that we will be going in more deep about the binomial coefficients. So basically what is happening is that we are distributing this power m over two things, okay. So in that case, what was happening, when I'm saying I'm distributing the power over two things, the sum of the power was always n. That is what, like if I have, suppose maybe 5 chocolates, okay, and I want to give them to 2 children, so whatever options I have, those were basically that thing, that if I give 1 to the first child, automatically second will be getting 4. So that was the logic that we were using in the binomial. Those NCR where we are saying x raised to power, this was n minus r and y. So whatever I am giving to y in this case, the remaining is automatically going to x. Now in this case, instead of 2 people, there are n people, okay. So if you have a knowledge of binomial, basically distribution, the combination part, for this again I will say the prerequisite for this thing to understand will be permutation and combination, and in that also permutation and combination. And in that specific, if you have heard about the beggar's dilemma, the distribution, when you're distributing n coins among p beggars, okay, so this same kind of formula is there, okay. So same thing we are doing, okay. So whatever things we are distributing plus among whatever things we are distributing minus 1c. Now n here is, please note that whatever things we are distributing among, that is more important. So that thing we will keep on both sides. The number of things which you are distributing, that we will keeping in the upward side, okay. So a better way to understand is, you can just start thinking of maybe from 2 only, that when these are the number of terms, again these are number of possible cases, okay, that we are gonna discuss, that what does this represent. So what you can do, go back and see for binomial, okay, when this is 2, what this formula will turn into. So this will be n, so n, this will be 2, you are distributing among 2 minus 1, c2 minus 1, which is n plus 1 c1, which is nothing but n plus 1. If you remember, for index n for binomial, we had n plus distribution. So basically those were actually the possible cases starting from 0 to n. We are distributing for the first person starting with 0, 1, 2, 3, 4, 5, 6, and then finally we are going for n things, okay. So you can correlate, and I guess if you're stuck in this, please first of all pause this right now, continue it later on. First go for this and understand how the distribution is done, okay. Second point again is, sum of again all coefficients is obtained by putting as that I've already mentioned, that will always be putting all the things 1 here. Why? Because whatever in expansion, it will be coefficient plus into multiplication of terms. So if we put all the terms 1, so in this case it will be m raised to power. Now most important point which is now appearing is again this part, that coefficient of this thing. Now what is this thing? Okay, let us discuss this in greater detail. Okay, so what I'm saying is that if I want, suppose in this expansion, a plus b plus c plus d, suppose raised to power 4. Okay, now if I am going for a coefficient of a square b c raised to power 1 d, obviously this is the possible option. No. Why? Because we cannot exceed this greater than 4. Okay, obviously you will see that whenever you're doing even a plus b plus c whole cube or square terms you have done, the highest power will never exceed the index. Okay, so if we are going for this, maybe like you are searching for a coefficient of a cube c. So how we will do that? Again, the coefficient of this will be power factorial over whatever powers you are using for here in this. So this will be by 3 factorial, 0 factorial, 1 factorial, because you are using power 1 here. Okay, and last one will be 0 factorial. So this will be basically 4. Now this is what is actually written here, that instead of, why it was looking complex, because it was in terms of n basically. Okay, so this was till n, here we had till 4. So x1, x2, x3, x4, which were a, b, c, d, and these represents the power. Okay, so the total, it should be, again it should be noted that the overall powers for whatever coefficients you are taking, it will always be index. That is true for any expansion, because that the index basically represents the degree of variation in a particular term. So degree of variation is always same, whether you take one variable, whether it has power 4, or you take two variables, 2 each. Okay, so power has to be always same. Okay, so this is the coefficient, a very very important thing. So now if I give you anything in the world, that okay, you can verify also your binomial from this. Okay, so if for the case of binomial, okay, what we were doing here, that we were going for NCR. Okay, so NCR, what does it actually means? N factorial over, now in this case these were 2 and 1. Now if you have two terms, now what will the power of second one will be? Total minus first. So that's what we were getting here, that r factorial was the power of 1 and the remaining was the same thing. The same thing is verified. Now the things looks quite easy. Okay, even if I give you 10 terms in the bracket raised to power anything, you can go for any variable term. Okay, even if I ask you now x plus y plus z plus w plus something, maybe x1 plus x2 raised to power 6, now, or maybe 16. Now if I want you to find a coefficient, okay, you can always, okay, see the powers. So 16 factorial divided by whatever powers of 6 things you need, and please make sure that the sum should be always power. Okay, so that is a very important thing. Okay, and again one more important point I would like to bring other than multinomial will be that, like we did for 1 plus x raised to power n, if you remember it. Okay, similarly there is a concept like if you are having two expansions with different powers. Okay, so we can again correlate their coefficients, and again that will be same. Okay, so if you are looking for some coefficient here, okay, so again we can have this expansion. So this will be basically 1 plus x raised to power m plus n, and this will be nc0 plus nc1 plus nc2. I'm not writing x because finally we are going to pick the powers, and you can understand, okay, nc2 means x square by now. So next one will be mc0 plus mc1, like this. So in this, again, if I am picking, so what will be the difference? Instead of 2n, basically you are having m plus n. That is the difference, mcr. So what will be the coefficient for that? Again, you will be picking, if you are picking 0 from here, nc0, you will pick mcr means that has to be MCR. Why? Because x raised to power r from here, x raised to power this you will multiply and this will be that if you multiply it by 1, that has to be MCR minus 1. Okay, so that thing you can keep in mind, that if you're increasing this one, the other one has to decrease by 1. Okay, so whatever we are doing here is that again the difference we are keeping same. Okay, this one is going 1 up and this one is going 1 down. Okay, the overall power, the overall sum of these things will be same. Okay, the same thing which we did for basically n plus n case, there both the terms were same. Okay, if you remember, and there one thing which we used was, instead of 1 plus x, we used 1 plus 1 by x. So again, for different expansions there will be some changes, so again that you have to incorporate. So there we were using actually the coefficient of n plus r, that's why that there's a slight difference. But here this will be going, the series will be like this. So you can pick that series also, just use here 1 by x and you will be getting the similar results. So try this, and again the things will become very easy for you if you understand multinomial. Look at the broader picture. The only prerequisite needed for that is that when you are going for m things and distributing in n things, okay, so that thing you should know, that how you are able to distribute. If you are distributing suppose 6 thing among 3 people, so you have to make different combinations, that if first one is getting 1, now I have to distribute remaining 5 in next 2. So again that you can either go for binomial, or you can think of it as case by case. If you're giving this 0, this will be getting 5, 1, 4. So for 1, these many cases will be there, like 2, 3, 4, 5. Okay, so you can think like that. You can go back, read the theory, and this multinomial becomes very easy, and hence binomial will become even more easy. Okay, I guess the show was awesome, and you must be now feeling okay. A multinomial theorem looks a bit simpler, but mind it, it's not. Okay, so you need a great deal of practice in this topic, and I'll suggest that please go at least 10 to 15 questions based on this topic from wherever you can find. Plus you will be finding questions based on this in the test paper which you must have got. Stay tuned for the next part.